Let us start the miscellaneous exercise. We will start this exercise with the examples that I have here. So the first example that I have is how many words with or without meaning, each of three vowels and two consonants, can be formed from the letters of the word involute. Now involute has got these letters INVOLUTE. So how many vowels do I have in total? 1, 2, 3, 4. So I've got 4 vowels and 1, 2, 3, 4 consonants. 4 consonants. So I've got 4 vowels and 4 consonants to choose from, and I need words containing 3 vowels and 2 consonants. So I need these 5 letters that contains 3 vowels and 2 consonants, right? Out of these, so in how many ways will I be able to select them? If I need 3 vowels, out of 4 I can select them in 4C3 ways, and 2 consonants out of these 4 available consonants I can choose in 4C2 ways, right? Once I have chosen these words, or once I've chosen these letters, how many letters do I have now? 5 letters, and I need to form words with or without meaning with that. Up to this point I have chosen these 5 letters. Now I have got 5 letters including 3 vowels and 2 consonants. I have got them, right? Now I need to arrange these because I need words with or without meaning. So in how many ways can you arrange these 5 letters is 5 factorial. So you need to multiply these 3 and you'll get your answer. So what is 4C3? 4C3 is 4, and 4C2 is 4 into 3 by 2 into 1, that is 6, and 5 factorial we know is 120. So this is 24 into 120, and which will be equal to 48, 28. So 2880 total words can be formed using the letters of the word involute, each having 3 vowels and 2 consonants. Okay, right? These words should be each of 3 vowels and 2 consonants, right? So each word is of 5 letters, and out of those 5 letters there should be 3 vowels and 2 consonants. I hope you have understood the question. The way we did it was, first of all, we chose the letters according to the given conditions. We chose 3 vowels out of 4 available vowels. We chose 2 consonants out of 4 available consonants. Once we have got these 5 letters, we arranged them in 5 factorial ways. That is what I have done. A group consists of 4 girls and 7 boys. So this is a group of 4 girls and 7 boys. In how many ways can a team of 5 members be selected? So I have got total 11 members, right? And I need to choose a team of 5 members. In how many ways can I select this team? The first part is when there is no girl on the team. So when there is no girl on the team, I have to choose the entire team of 5 members from 7 boys, right? Because there is no girl on the team. So out of these 7 boys, in how many ways can I choose 5 members? 7C5 ways. So the answer will be 7 into 6 by 2 into 1, because 7C5 is nothing but 7C2, right? So this will be equal to 21. So in 21 ways we can select a team where there is no girl out of these, right, based on this question. Now at least one boy and one girl. So at least one boy and one girl should be there. So that means now we cannot choose a team where there is no girl or where there is no boy. In fact, we cannot choose a team where there is no boy because there are only 4 girls. So even if I take all the girls, I still have to choose one boy for it to be a 5-member team. But let us make the possible combinations. If I choose one boy and 4 girls, I can make a team. If I choose 2 boys and 3 girls, I can make a team. 3 boys, another way to choose the team can be 3 boys, 2 girls on the team, and then there can be 4 boys and 1 girl on the team. So these are the possible ways to choose the teams, because I can choose one girl, two girls, three girls, or all four girls, right? I do not have any other option to choose from. So these are the possible combinations. Either I can choose this one boy and four girls, two boys and three girls, three boys and two girls, four boys and one girl. Now these are options, right? Either this combination or this or this or this. Why I am writing this or? Because once you get your answer for this and this, you have to add these to get your final answer. So one boy, four girl. One boy out of these seven boys. How many boys in total I have? I have seven boys and four girls to choose from, right? So this case, one boy, four girls, 7C1 and 4C4. So there is this and, so I have to multiply. Then because of this or, plus two boys, 7C2, three girls, that is 4C3, plus three boys, 7C3, two girls, that is 4C2, and four boys, 7C4, into one girl, that is 4C1, right? I just need to add them and I'll get my answer. Let us see. This is 7, this is 1, so 7 into 1, plus this is 7 into 2, so 7 into 6 by 2 into 1, 21. This is 4C3, so 4, 7C3, okay, this is done. So plus 7C3 is 7 into 6 into 5, 3 into 2 into 1. 4C2 is 6, plus 7C3 and 7C4, these are going to be the same number, right? So let us first of all calculate this number. This is 35, right? So this is also going to be 35 and this is 4. This is 7, this is 84, this is 35 into 6. So 35 into 6, 6 into 30 would have been 180, and 5 into this is 5 into 6 is 30, so 210. 70 into 2, that is 140. This is how you need to think about calculations. So this is 250, 350, 357, 361, and then 80. 361 plus 80 will be 441, right? So these are the number of ways you can choose a team having at least one boy and one girl. Okay, now let us look at the next part, at least three girls. So I have seven boys and four girls to choose from, and now the question is at least three girls should be on the team. So first thing that should come in my mind is how do I convert it into exactly, at least to exactly. So either exactly three girls should be there or exactly four girls should be there. I cannot have more than that because this is the least that I can have, three girls. So I can have three girls or four girls, right? So these two cases will be there. So first case is three girls and remaining two from boys, right? Three girls and two boys, four girls and one boy. So these are the ways, one boy. These are the ways we are going to select with at least three girls. So either this way or this way. Now what is this? 3 girls and 2 boys. 3 girls out of 4 girls can be chosen in 4C 3 ways, and 2 boys out of 7 can be chosen in 7C 2 ways. Or there is this another case, 4 girls, 4 out of 4, 4C4, 1 boy out of 7, 7C1. So what is this result? 4C3 is 4, 7C2 is 7 into 6 by 2 into 1, so 21, plus this is 1, this is 7. So if you notice, this is 84 and this is 7. 84 plus 7 will give you 91. So in 91 ways we can choose a team having at least 3 girls out of 7 boys and 4 girls. Okay, I hope we have done all the parts of the previous question, right? So let us focus on the next one. Find the number of words with or without meaning which can be made using all the letters of the word again. So I have got these letters A, G, A, I, N, right? If these words are written as in a dictionary, what will be the 50th word? So the first part of the question is we need to find number of words with or without meaning that can be formed using all the letters, right? So the first part will be answered as 5 factorial, 1, 2, 3, 4, 5 factorial divided by, I've got 2 alike, AA. So I've got 2 A's. So I'll divide it with 2 factorial. This will be my answer for the first part, that says how many words with or without meaning using all the letters of the word again have to be formed. So this will be 60 such words can be formed. Let us look at the second part. If these words are written in a dictionary, so what will be the 50th word? So how do we arrange the words in dictionary? We arrange them alphabetically. So the first word out of these 60 words we are asking, right? So I am still using all the letters here. So the first word using all these letters, right? Out of these 60 words, the first word will obviously start with A. So let me fix this left position and then look at these 4 positions. So these are 5-letter words. The words starting with A, the words that start with A, starting with letter A, how many will be these? So if I fix A here, in rest of the 4 letters G-A-I-N, the number of ways I can arrange these 4 remaining letters in these positions will give me the number of words starting with A, right? So how many words will I have? I can arrange 4 remaining letters in these 4 places in 4 factorial ways. So the numbers, the words starting with A are 4 factorial in number, which is 24. So these are 24 such words. Now what is the next alphabet after A? G, right? So the number of words starting with G will be equal to 4 factorial divided by 2 factorial, because when the words start with G, I've got these 4 letters A, A, I, N to arrange at these 4 places. I've got A, A, I, N. So I've got 2 of the letters which are alike. So I have to divide it with 2 factorial. So it will give me 12 such words which start with G here. Okay. Then the words will start with I after that, right? I'm going in alphabetical order. So I'm observing in my mind A, B, C, D, E, F, G, H, I. Now I'll start the words with I. So obviously the word starting with I will also be 4 factorial by 2 factorial. Why have I divided it with 2 factorial? Because 2 A's are present. So 12 such words. If you see till now, the total number of words that I've got are 24 plus 12 plus 12. So 48 words are completed. So the next word will start with, obviously it will start with N, right? So the next word will start with N. And I need to see what will be the 50th word. So the 49th word, can you tell me the 49th word? We know that dictionary is arranged, like words in a dictionary are arranged alphabetically. So the next word is going to be, when I've got A here, and then G here, and I here. So this is going to be the 49th word. I have written this 49th word just by observation, because I know the basics of a dictionary, how the words are arranged in a dictionary. They are arranged in alphabetical order. So when first letters of the words are arranged, then second letter we have to see. That is also arranged alphabetically. So if the word starting with N, the second letter will start with these letters will also be arranged alphabetically. So the second letter, I hope you know how the words are arranged in a dictionary. If you don't, then you find a dictionary and look at the words. So this will be the 49th word, N-A-A-G-I. And what will be the next word? N-A-A will still be there, and then I will come here and G will go there. So this is going to be the 50th word. 50th word that I require. I hope you got the idea. So what I do in a dictionary is that if I start words with N, right, and rest of the letters that I have are A-A-I-N. So the first word that starts with N will be A-A. Now these are also to be taken. First I'll take A, then I'll take G. Where is G? A-A-I-G I have. So after A, I'll take G. So let me take G. After G, I'll consider I. So let me consider I. So this will be the first word that starts with N, which happens to be the 49th word if I arrange these 60 words in a dictionary arrangement. So what will be the next word? Now that I've taken this word, next word will also start with N, A, and then I've taken already GI. So the next word will have IG here, right? After this, I will consider this position. So the 51st word, what will be the 51st word? So what will be the 51st word? This is my 50th word, right? So the next word will start with N, obviously, because I have got 12 words which start with N, right? So I have written 2 of them, which is, this is the first word that starts with N, this is the second word that starts with N. So the third word that will start with N will have next letter as A, right? And the third letter here has to be changed now, because if I take A here as my third letter, then either GI will be here or IG will be here. So I have already considered these two words, that 49th and 50th word. I am looking for the 51st word now. So what will come at this third place now? So if I go alphabetically, after A, I'll take G here. So once I have taken G here, now the next letter here, which letter will come here? The after G, I will have to place I here, right? So I will come here, and then N will come here. So this will be my 51st word. Okay, anyhow, I had to find the 50th word, which is this. Okay, let us look at the next question. How many numbers greater than, what is this number? 2, 4, 6. So this is 10 lakhs. Can be formed using the digits. So these are 7 digits. 1, 2, 3, 4, 5, 6, 7. Okay. So any number that starts with 1, 2, 4 will be okay, will be greater than this number. As there are 7 digits, I'll use all these digits, okay, and any number that starts with 1, 2 or 4 will obviously be greater than this, because this is the lowest 7 digit number, smallest 7 digit number, and I've got these 7 digits. So if I use all of these and start the numbers with 1, 2 or 4, that is how I'll be able to form the 7 digit number. So all of these numbers will be greater than this. So the numbers starting with 1, 2 or 4 will be greater than this. So if I ask you, what is the total numbers that you can form using these digits? These are 7 digits and using all the digits, right? So using all these digits, you can form 7 factorial numbers divided by, I've got 3 twos and 2 fours, right? 5 and then 6 and 7. Okay. So I have to divide it with 3 factorial and 2 factorial. So these are the numbers that I can form using all these digits. But there is a problem in this number here. What is the problem? That it contains those numbers also which start with 0. And I don't require those numbers because those will be 6-digit numbers, right? And will be smaller than this. So I need to exclude these numbers which start with 0. So how can I exclude? I can subtract those numbers that start with 0. So let me fix 0 here. Let me fix 0 here and see how many numbers can I form by fixing 0 here. So rest of the 6 places can be filled in 6 factorial ways by, I've got 3 twos, so I have to divide it with 3 factorial, 2 fours, so I'll divide it by 2 factorial. Let me subtract this, and these are the numbers that are greater than 10 lakhs, which can be formed by using these digits. So let us see. I can take 6 factorial by 3 factorial into 2 factorial outside, and I'll have, from here I'll have 7, and from here I'll have 1, right? So this is 6 factorial is 720, and 3 factorial is 6, 2 factorial is 2, so 12, and this is 6, so 2 and then 360. So 360 will be your answer. Next question is, in how many ways can 5 girls and 3 boys be seated in a row so that no 2 boys are together? So there are 5 girls and 3 boys, right? And they have to be seated in a row. Let us first of all see how the girls can sit. Let us say that these are the positions where the girls are sitting. Now 3 boys are to be seated so that no 2 boys are together. So how do I make that arrangement? Whenever these kind of questions are there, that no 2 boys are together or no 2 things are together, what I do is I fix them, or I make them sit in these gaps. What gaps? These gaps. So if they sit at these places, how many gaps will be there? When I've got 5 objects, 1, 2, 3, 4, 5, then there will be 6 gaps between them, right? So this is also a gap. 1, 2, 3, 4, 5, 6 gaps. So out of these 6 places, I can arrange, or I can make these boys sit at any of these 3 places, and then this condition will be satisfied, that no 2 boys are together. So first let the girls sit. So in how many ways can these girls sit at these 5 places? Obviously 5 factorial ways. Now out of these 6 gaps, let me choose 3 where the boys will be sitting. So 6 see 3 ways I can choose the 3 seats, right? Now in those 3 seats, these 3 boys will sit in 3 factorial ways. Okay, so this is 120. This is 6 into 5 into 4, or you could have written it. Okay, let's write it. 3 into 2 into 1. Okay, and this is what? This is 3 factorial. So this is again 3 into 2 into 1, right? So what is the answer? This is 120, right? 6 into 5, 30 into 4, 120 into 120. So 144 and then 2 zeros. In these many ways, 5 boys and 5 girls and 3 boys be seated in a row so that no 2 boys are together, right? So how did we do that? We first of all, we let the girls sit in 5 factorial ways. Now once the girls are seated, I have got 6 gaps where these boys can sit, because no 2 boys have to be together. So out of these 6 gaps, I have chosen 3 gaps for the boys to sit, and in those 3 gaps boys can sit in 3 factorial ways. Rather than saying this statement, I could have also said 6p3 directly, right? Which would have also given me the same answer, but just for the clarity, I have first chosen the seats and then made the boys sit in 3 factorial ways. So this product will give your answer, which is 14400. Okay, so these were the examples of miscellaneous exercise, right? In the next lecture we will start the questions of the miscellaneous exercise.